All right. Dion, do you mind closing the blinds behind you? Please and thank you. Just the one. There you go. Page 15. Um, probability with permutations combinations. I need to tell you that odds do not go away. Okay? Odds can still be stated at any point. If you're able to come up with a probability, you can state the odds. Okay, page 15. In general, you will follow these steps, right? Determine if order matters. If yes, then we'll use perms, right? If no, we'll use combinations. Determine the total possible arrangements given no restrictions. This is the sample space, or basically your universal set. Pay attention, okay? This is N of U, basically. Determine the total desired or favorable outcomes, right? That's based on the conditions or restrictions that you will be given. Okay? And so then at the end, you'll write your final answer as a fraction. Reduce ideally, but again, I'm not going to mark it wrong if you're not reducing, because I'm more interested in, do you know how to set up that probability, right? Do you know how to come up with that probability? That's what this unit is all about. So this is basically what we're going to end up finding, right? Our probability like this as a fraction most of the time. So let's do a few examples here. Jump right in. There are 4 band and 6 dance students. Okay, a teacher would like to select a team of 5 students to represent Sisler at a convention. So, what do you think? Does order matter? Does order not matter within the groups? Because you're creating teams, right? And within the team, it doesn't give any specific jobs or positions to be filled. You're just making teams, right? Yes, you have different categories of students, but really the teams, there are no specific positions within the team. So order, I will say this, order within the team does not matter. Therefore, we'll use combinations. So A, what is the probability, guys? I'm not asking anymore how many arrangements. I'm asking you for probability. What's the probability? So you know it's going to be a fraction, right? Of having a team with exactly 3 dance students. Exactly 3. I put in the word exactly, but I could have just written it like this. 3 dance students. And then you have to know, okay, if it's just written like that, it's not at least, at most, or right? It's exactly 3, then let's make the group. Okay, so watch how I'm going to approach this. I'm gonna find my universal. That looks like an H, right? Let's make sure that's an N. N of U is all possible teams that can be made. And how would you come up with that? Just teams of 5. With almost ignore what was just said here. Just saying, hey, how many teams of 5 can I make, right? How many possible ways are there to make teams of 5? So we're going to go ahead and do that. Out of the 10 students that we have, right, 6 and 4 is 10, right? We're going to choose 5. Okay. And let's calculate that. If you type that in, you get 252 teams. Okay, no restrictions or conditions, right? So that would just be, hey, this is if there's no restriction given to me, I could potentially make 252 different teams. Okay, and so my N of A is basically N of 3 dance students. I'm just going to write it like that, 3 dance. Okay, that's the N of A. That's like the event that I'm looking for, right? How many of those could I make? That's specific now. That's your favorable outcomes. So I'm going to focus on dance students first. So if I look at now when you're making, right, when you're picking from the 6, you're going to choose 3. And what else is implied? 3 dance, which means 2 not dance, right? 2 students that are not, because you still need 5. Okay? So in this case, how many non-dance students do you have? Exactly 4. So we're going to choose from the 4, we're going to choose the remaining 2. Okay? And if you allow me to do this, I'll just, right? That's still a team of 5. Bless you. Team of 5, right? So let's go ahead and compute that. And I think it goes without saying, you know how to type this in. You were really good at that. So I'm just going to give you what that is. 20 and 4 choose 2 is 6. Question. Should this number be greater or smaller than my n of u? It should always be smaller, right, guys? So sometimes I see students just times, multiply, add, blah, blah, blah. They get something bigger than your universal. You can't have that, right? This is like the box around my sets, right? This. So this has to be smaller, right? Or else there's something wrong. So this is 120 teams where it meets that restriction of having exactly 3 dance students. So now we're going to come up with our probability. Probability of 3 dance is 120 over 252. I took the liberty to reduce this one using the calculator. So that's what that would be. And I want to make sure you know this part, or you get this part right. Don't get this part wrong here. So you go 120 divided by 252, and then we go 0.4762 or 47.62. And here's what I want to say. Don't put equal signs in between these. Because when you're rounding, it's no longer equal to, it's approximately, right? So we just go comma, we just like, hey, this is approximately this, approximately that. Or we could do the squiggly equal signs, but just go commas, and then you're saying these are the 4 ways, or the 3 ways of representing it, right? Let's do the odds here. Odds of 3 dans, right? 4, 3 dans. How would we write odds? I'm just going to go arrow because I don't want to go equal sign. I don't want to see equal sign next to the odds, right? If you wanted to write the odds of having a team with exactly 3 dance students, it shouldn't be really that difficult. You choose one of these fractions. I will choose the reduced one. So it would be 10 to 21 minus 10. So 10 to 11. Does that make sense, what I just did there? I hope so. I think the key to remember is there should not be a 21 in your final odds, right? The universal should not be there. Mr. Dixon, could I have used this one? 122, yes. Yeah, you could have 122, 132, right? You could have used that, no problem. What about the next one? The probability of having at least one band student. Right? The at least is a problem, right? It's not, you can't say it's just one case. There's multiple cases where that can happen, right? Because it's saying 1 band, 2 band, 3 band, and so forth. Can I change this? Can we change it to dance? Please change it to dance. There's a problem, right? We only have 4 band students. I don't know if you've realized that, right? And so we couldn't make it all of them being band students because we have a team of 5. So I won't throw that at you, right? So let's just change that to dance and we're all good to go. So we're going to figure out at least one dance students would be total minus no dance student. Because it's saying one dance or two dance or three dance or four dance or five dance. That's what this is saying. It's like, wait a minute, that's a lot of cases to consider. Let's just consider the case where there are 0 dance students to subtract it from a total, then we're left with all of these, right? So total is 10 choose 5. This is already determined in way up in A, right? We did this minus no dance students. So we have from the 6 dance students, we're going to choose 0, and that means that it's still a problem, right? Houston, we have a problem. How should I fix this? What's the least damage here? We're going to say this. We're going to say this here. Under B, you're going to make teams of 4. Okay, please add that. We're making teams of 4 in this particular case. Teams of 4. Actually, it's a nice change to the question. So 10 choose 4. That would be your universal in this case. Minus 6 choose 0 times 4 choose 4. Okay. Silly mistake. Anyways. 10 choose, so I need to redo this. So you bear with me here. 10 choose 4 is 210, so it makes sense, right? Minus 6 choose 0 is just 1, right? And 4 choose 4, is that 1 as well? I'm just going to double check. That is 1, yeah. So it's basically 219, right? 210 minus 1, which is 219. 209. 209. Is it Friday? It must be Friday. 209 teams. There you go. 209 teams. So that means that our probability of at least one dance is going to be what? 209 over what goes in the denominator? It's going to be our total number of teams out of 4, right? So we're going to make this out of 210. Okay. And we're going to leave it like that. I will just turn it into a decimal yet. 0.9952 or 99.52%. Okay. Wait a minute. The probability of getting at least one dance at the Halloween dance? Is that what we're talking about? No. That's not. Don't get your hopes up, right? There's just at least one dance students on the team. Let me highlight a few things here. 210, right? Can I also highlight this? Because you might not see it. You're like, why did we all of a sudden make teams of 4? Like, what's happening, Mr. Dirksen? Just say Mr. Dirksen made another mistake, right? If you're keeping track, we're up there on that track record. I get too excited when I make these questions, so then I change everything up and don't follow through sometimes. But at least we caught it, okay? What are the odds of having at least one band student on the team? So we would just take that, right? 209, 210 minus 209, right? That's 209 to 1. The odds are pretty good. All right, next page. How are we doing with time? We're still doing okay. So I want you to at least, because if I just go through it, you're always like, yeah, you're just copying down blindly. I don't want you to do that. So let's go to the next page and see if you could answer that question, just that question right there. John, Ethan, and Adriana, would you be able to answer that? Would you be able to come up with a probability? Watch this, guys. Not determine the number of ways, determine the probability. How would you do that? Just use a pencil, write lightly, give it a try. NA, NU, right? Come up with a universal, come up with a specific. Yeah. Right. Let's get back to it, okay? So when you're looking at this question, pay attention, okay? There's first, second, and third place mentioned. So specific positions, right? So order matters, right? So this is going to be a Perms. And it's a, yeah. Question? You're not saying that John has to be first or Ethan has to be first. You're just saying that like those three can be in any order as first, second, and third position. So we're not putting like a 1 to the first or a 1 to the second, right? Like within those three, you can just have any of those three placed in any position. Because there are specific positions, it does matter where like if, for example, you have John, Ethan, and Adriana, or John, Adriana, and Ethan, like it does, because there is a specific position mentioned, like this is first, second, and third, it would order would matter in terms of looking at that. It's a different outcome, right? We would consider these two as two different outcomes because when they're standing on the podium, right, first, second, and third does matter in which order you arrive, right? That is what this is saying. So I understand if that could have thrown you off, right, thinking it's combinations, right, because it basically is kind of saying order doesn't matter. But this is just indicating the fact that we're not saying that Ethan has to be first or John has to be first. Does that make sense? Okay. That's a good question. I'm going to erase this because I need this space. Okay. So I don't know if you want to use the fundamental counting principle. So you have 3 and then another 10 runners, right? So 13, 12, 11, or you can go 13, pick 3. What is this? What are we finding here? I'm considering all runners, right? So this is the N of U, so to speak, right? So 13, pick 3 is, let's get to my, anybody have that? 13, I just went to 13, pick 3, and I didn't actually calculate. So that's 17, 16 ways, right? That if you consider all 13 runners. N of A is specific to just John, Ethan, and Adriana, right? So that would be 3, 2, 1, or 3, pick 3, right? And that's just 6. 6 ways. So the probability in this case, we'll just go probability is 6 over 17, 16. And that is 0, watch this. This is 0.0035, right? Or 0.35%. Okay. You want to do odds? Odds of, right, would be 6, 2, 17, 10, right? Odds against would be just flipping this 17, 10 to 6. So that is also, it's always there for you. Yeah. Because you subtract, right, to get the knot, you go universal minus the ways that they arrive. You want to do that here? 17, 16 minus 6. That's how I came up with that. Okay. You should not have the universal in your odds. Let's just put it that way. Ever. Okay. Okay. If Fiona tossed 5 coins, the first 2 landed on tails, right? Determine the probability of the other 3 coins to have at least 1 tail. Let me introduce the concept of tree diagrams. They're going to be extremely helpful in this unit. So the first 2 are tails. So tail, tail. There's nothing that you can argue with that. But then from then on, you have a third coin. So that's heads, tails, right? Then you have a fourth coin, heads, tails, heads, tails. And then you have the fifth coin, heads, tails, heads, tails, heads, tails, heads, tails. Okay? So now let's put our outcome down. So if you go this branch, it's tails, tails, and then heads, 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 right? If you go down this branch again, tails, tails, right? 2 tails, 2 heads, and 1 tail. You know what I'm going to do? Every single one I'm going to go tails, tails right away. Because that is the case for every single outcome. Because we know that the first 2 coins did land on tail. Can I zoom into that? Do you want me to zoom in? Too many T's and H's, right? Okay, so if I go down this branch, here it's heads, tails, heads. Then it's heads, tails, tails. Then this next one is tails, heads, heads. Tails, heads, tails. And then it's tail, tail, heads. And the last one will be all tails. Okay. The first 2 is already set here, right? Like you don't have to even think about that. That's already has been determined. You've been given those outcomes. So you basically are just worried about the remaining 3 coins. So it's really 2 times 2 times 2. There's still 8 different outcomes, even though they could have told you we tossed 10 coins, right? And they could have given you the outcome of the first 7, let's say, right? If there's 3 tosses left, it's still 2 times 2 times 2, right? 3 coins. I'm going to zoom out again a bit. 3 coins left, right? So it's 2 times 2 times 2, 8 outcomes. Okay, there are 8 outcomes to be considered still. So at least 1 tail. That would be all of this, right? Because this is the only case where you have no, sorry, I messed this up. Mhm. At least 3 tails, guys. Can you cross this off? At least 3 tails, I meant to say here. At least 3 tails. Okay, so if you consider, right, this gives you 3. You still have 3, and it actually increases as you go down this outcome, the tree outcome, right? This is the only one that has 2, so at least 3 tails would be here. At least 3 tails. Okay, but we want the probability. So this is your NA. Okay, this is your NU. That's the universal, right? There are 8 different outcomes. Even though you're like, but Mr. Dixon, there were five coins were tossed. But if they tell you the outcome of the first 2, it's still just 3 left to determine, right? You can tell that there's only 8 outcomes here. So probability would be 7 outcomes out of 8. Okay, 7 out of 8 would be your probability there to land at least 3 tails. Okay. At most 2 heads. What's the probability of the other ones of having at most, right? At most 2 heads. Let me grab green. I'm going to use green for that one. At most 2 heads. So let's go and see at most, right? So 0, 0, 1, or 2. So that'll be 0, 1, still 1. There's 2. This one has 1. This one has 2. And 2, right? So it's basically the same scenario, right? 0, 1, or 2. It's still talking about this part right there. So it's just asking for a different probability, but we're still talking about the same number of outcomes, right? 7 outcomes. Okay. So probability of at most 2 heads is going to be 7 out of 8. Okay. So use tree diagram when you have questions like these. If you can't picture the number of outcomes, use a tree diagram. Okay, tree diagram. Very important to know how to do that, okay, to get this right. I want to do one more question on the back side, and that'll be it for today. Okay, in a contest, there are letter tiles spelling out the word Winnipegosis. The tiles are being turned upside down and shuffled. The contestant is then asked to rearrange the tiles and turn them over. If the tiles spell the word Winnipegosis, the contestant wins $10,000 cash. Determine the probability of the contestant winning the prize. Okay. How many ways can you get it right? How many ways can you spell Winnipegosis? There's only one. One way to win. So in this case, it's very easy when it's something like this, like your NA is done. Okay. So we're going to focus on the NU. How would you do the universal in this case? What does this involve? we have words with repetition, right? Remember that? Okay, so it's just let's count the letters: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that'll be 12 factorial over, I see 3 i's. Okay, so 3 factorial, this would be the i's, right? And I see 2 n's. These are my n's. And what else is there? The s's, right? 2. So this is my s's. Is there anything else that I'm not seeing? The what? I think we got it all. Okay, so 12 factorial is 479, 001, 600. And then this down here, 3 factorial is 6 times 2 times 2. So that's really 4 times 6, which is 24, right? If you divide that, you get 19,958,400 ways. Okay. Therefore, the probability of winning would be 1 in this many possible ways. This is going to be too small. Like, try this as in your calculator. If this ever happens, you just don't worry about it. You leave it as a fraction, right? Right? It's too small for our calculators. Okay? Too small. Leave as fraction. Okay. I'm going to stop here. The homework is on the back side. That's page 321, 1 to 6, and 10. And I think I added, hold on one second. I added a questions in here from a worksheet. So I'm going to say do that first, page 19 to 20. Do that first in the book, and then that is textbook, right? Okay.